Welcome! In this explainer, we are going to crack the code on those growing visual patterns you see everywhere. You know the ones, shapes that grow in a really predictable way. But what if I told you you could predict the 100th step in the pattern without ever having to draw it? Well, that's exactly what we're going to do today.
Okay, so let's jump right in with a classic example using squares. Take a look here. We've got pattern 1, which then grows into pattern 2, and then into pattern 3. The real question is, can you spot the rule? How exactly is this thing growing from one step to the next?
And here's where it gets tricky. How many squares would be in, say, the 20th pattern of this sequence? Or what about the 100th? I don't know about you, but drawing all of those out would take forever. There has to be a smarter, faster way to figure this out, right?
And of course there is. The very first step to cracking this code is to forget about the pictures for a minute. We need to translate these growing shapes into the language of math. We need numbers.
So let's get organized. A simple table is honestly the perfect tool for this job. For pattern number 1, a quick count shows us 5 squares. For pattern number 2, we've got 8. And for pattern number 3, there are 11. See? Laying it out like this already makes things a whole lot clearer.
And just like that, our visual puzzle has totally transformed. It's not about squares anymore, it's a number sequence, 5, 8, 11, and so on. Now we can use some really powerful math tools to find the rule hiding underneath.
Okay, so with our numbers all lined up, we can start looking for the most obvious clue. How exactly does the pattern grow from one number to the next?
Now, this has a fancy name. Mathematicians call it the term-to-term rule. But all it really is the simple instruction that gets you from the first number to the second and from the second to the third. It's the most basic relationship we can find.
And if you look at our sequence, the rule pretty much jumps right out at you. To get from 5 to 8, you add 3. To get from 8 to 11, you add 3 again. So our simple step-by-step rule is just add 3. Every new pattern is just adding 3 more squares.
So here's the thing. This rule works, but it's not very efficient, is it? To find the 20th term, we'd have to start at 11 and just keep adding 3 over and over and over again. It's definitely better than drawing, but I think we can do better. We need a real shortcut.
So it's time to find the master rule. We need an all-powerful formula that links the pattern number directly to the number of squares. That's what's going to let us jump to any term in the sequence, instantly.
And our biggest clue is that add 3 rule we just found. Because the sequence goes up by a constant 3 every single time, it tells us that our formula has got to be connected to the 3 times table. So let's start with a hunch and test out this rule 3 times the pattern number.
Okay, let's see how our test rule holds up. For pattern 1, 3 times 1 is 3. But the actual number is 5, so we're off by 2. For pattern 2, 3 times 2 is 6, but we need 8, again off by 2. And for pattern 3, 3 times 3 is 9, but we need 11. Wait a second, do you see that? We are consistently off by exactly 2 every single time.
That consistent difference, that is the final piece of our puzzle. Since our rule is always too short, we just need to make one tiny little adjustment. We just have to add 2.
And there it is, the secret code, the formula for our entire sequence. The number of squares is simply 3 times the pattern number plus 2. This is the powerful tool we've been looking for.
All right, now that we have our formula, let's go all the way back to that original problem. It's time to see how this powerful little equation makes that really hard question incredibly easy.
Remember this guy? The question that seemed so tedious just a few minutes ago? How many squares are in pattern 20?
Well, with our formula, we don't have to count or add over and over again. We just plug in 20 right where it says pattern number. So the calculation is simply 3 times 20 plus 2.
3 times 20 is 60, plus 2 is 62. And that's it. Pattern 20 will have exactly 62 squares. No drawing, no repeated adding, just one simple, clean calculation.
So why does all of this matter? What's the main idea you should take away from this that you can use on other problems?
It really all boils down to this simple 3-step method. First, you turn the pictures into numbers in a table. Second, find that step-by-step increase, because that becomes your multiplier. And third, you test that multiplier and figure out the constant, the little number you need to add or subtract to make the formula perfect.
You know, this method of analyzing patterns and predicting what's next, it's not just for shapes in a math problem. It's a way of thinking that helps us find the hidden rules that govern all kinds of things around us. So the real question is, what other secret codes are out there just waiting for you to crack?
Hey, if this explainer helped you see the code hiding in the patterns, do us a favor and hit that like button, share it with someone who might find it useful, and let us know your thoughts down in the comments. Thanks for watching.